Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Carl Carlson.
And this is Fred Schenkelberg. Hey, Carl.
Hey, Fred. Yeah, I've got a really interesting question from a reader, listener on FMEA that I wanted to share with you and kind of talk over.
Okay. Well, you do seem to be the magnet for the FMEA stuff, you know.
Yes. Well, it because I enjoy it, and I think it probably comes across that I'm very interested in questions because they challenge me. This one was a really good question. He's referring to my book on effective FMEAs, and he says he talked about prevention controls, and the definition that I use, which is consistent with FMEA standards, has to do with what a prevention control is, and it on the design side, the prevention control is the method or the action that prevents the problem or could prevent the problem. And there's a specific definition which I don't really need to go into here because the question had to do with what can the prevention relate to the effect? And of course it can. In other words, you can prevent this severity, you can reduce the severity through certain mitigation actions.
You're using a lot of specific terms. To make sure I understand it is if I'm going to, I would call it mitigate or let's say I have a problem and the severity is it would catch on fire. It overheat and the failure is then it would ignite. If I do a design change such that it senses the temperature rise or the extra current draw or whatever the circumstances or increased pressure, is that it shuts it all down and it fails cold, is the way I would say it. The failure still occurs, but the severity is much different.
Exactly. And so the design prevention that's baked in or you've added to it is some type of reaction response system that mitigates the seriousness of the effect. And there's hundreds of examples in complex systems where you have a high severity initially, but then you have a sensor or monitoring in some way, and then you implement some response that reduces the severity.
Oh, you worked in the auto industry. I'm thinking of the bumper and the way cars in an accident basically protect the cabin, but the car, dissipates a lot of energy just by the way it's designed so that it crumples is the way I would describe it. Would that be an example of the severity of a head-on accident? It can be very, very high, but modern cars have gotten with airbags and with crumple zones and stuff like that. It significantly reduces the severity of injury and stuff.
Yes, you want, and that can be an example. Very common examples are where you have what's called monitoring and system response. Mm-hmm. You have a complex system where you're monitoring temperature, you're monitoring the
pressure vessels in chemical facilities or polymer facilities. They watch that pretty closely because losing a large vessel full of toxic chemicals is probably not a good thing.
Yes. You monitor vibration. There's a lot of things you can monitor. And the idea is that if you understand your failure mechanisms, if you have a failure mechanism that is beginning to occur, it's starting to activate, and you're monitoring, you see we got to do something, you can make a change in operation. You can add circulation, you can reduce the stresses. There's a lot of things you can do to reduce the severity of the effect before there's a catastrophic event.
Right. Okay.
And in an FMEA, his question came down to, well, do we get the probability? Does an FMEA assess the probability of the bad event, like the high severity issue? And he introduced it through the topic of design prevention, but his real question was, do we talk about the likelihood of the effect? And of course, the answer is
was that the effect of the likelihood of the effect as a. That's where I didn't quite get this question is
sure.
Because we do likelihoods for the causes, the underlying causes. And if you use a different type of approach, you can estimate the probability of that failure occurring from the main, the dominant failure causes. But that's not what he's talking about is because for any particular function or phenomena that we have, the severity of it failing, it could be it explodes or it goes cold or it doesn't work or it contaminates the product or it could be a whole litany of potential severities. Is it severity by, particular one after another, or is it the change in those? I didn't understand what likely it has to do with severity.
Let's get a very specific example.
Okay.
I'll take the bicycle. So in old bicycles, you have a brake pad. This example would go the same on a brake rotor. Mm-hmm. But let's say you have a bicycle brake pad, and the function is to apply friction to the wheel rim. You have some function that the brake pad,
right.
And you have a failure mode that the pad cracks. It's got some crack.
Right.
And a cause might be the pad material becomes dry due to wrong compound selected or something. You have wrong compound.
And I can think of a dozen of those UV,
a lot of different things,
degradation, all kinds of stuff. Yeah.
Now, if it cracks, what's the effect? Well, you have inadequate friction applied to the wheel rim, and therefore the wheel doesn't stop as well as it should, with the potential for an accident. So from a hazard point of view, what's the likelihood of the accident? Well, that's not what the FMEA does. The FMEA does not get the likelihood of the most severe event. In this case I'm giving you, you wouldn't know what the likelihood of the accident is. But there is a technique called hazard analysis where you do, or fault tree analysis. And so I have to explain to the reader that FMEA gets the likelihood of the pad cracking. Yeah. That's what the occurrence rating is.
That's what the occurrence is about. Is about the causes themselves. And that's where I think we often assume that, well, if the pad cracks, we're going to have, and now I get it. Now we have the likelihood that there's an accident, but it's not a one-to-one relationship. Not every pad crack is going to lead to, not stopping as you head into an intersection.
You might navigate your way to a safe stop.
You might notice the crack and replace it before you have an accident.
That's correct. So and this is so often happens in FMEA, because in FMEA, you're going to trace the propagation of the effect from local to next to end. And then I use the word potential, because you're not for sure going to have an accident, but you have the potential. And in an FMEA, we're going to make the brake pad more robust. And we might take some actions to mitigate the potential for accident by some other technique. Like you could imagine if you had a rotor brake and there's something wrong with the rotor, well, you have an electronic bike, you have different sensors possibly you could install that say, hey, we got a problem with the rotor where you could not have enough friction to stop. And there's buzzing going on and the bicycle rider pulls over before that problem. You have this on brake pads on vehicles.
I'm not riding that bike. It'll have an extra 10 pounds on it. It's, I get the idea. And I think I've actually, and I know I've experienced this thing, is like, that's the most severe thing that can happen. But the chance of that being the only thing that happens is almost nil. It could happen. It'd be very, very rare that the stars line up, that he ignores the quality of his bike. He has this faulty brakes. The riders notice that it takes longer to stop. But in normal conditions, you can deal with that. You just, you respond and start braking sooner. But in an emergency or in an accident type circumstance, and if you could stop like a new pad would stop you, you wouldn't be in a 4-lane freeway or highway with cross traffic going. And
that's right.
Yeah.
So now what you want to do, Go ahead.
But the idea is, yeah, I get that. If you have like 5 major severity or, severity things listed for something, if that brake pad fails, then here's the top things that could happen. I can see that being ranked but the FMEA in and of itself says these, I like your word, is potentially could happen, but we're not going to put a number on it.
We're not going to put a number in the FMEA.
Yeah.
So let me explain a couple of things here for listeners. In the FMEA, you're not going to put a number on that probability of the bad event. However, you will use the severity rating of the worst event. So the severity would be high in that case of the brake pad cracking. But the occurrence, you're going to have to estimate what the likelihood is.
And that's based on the mechanisms that would crack a brake pad in this example.
That's correct.
Right.
And so now let's transition to a technique that will get you the probability of the bad event. And I have an article. I'll tout the article here. It's on Ascendo Reliability. It's called Relationship Between FMEA and Risk Management. There's a part 1 and a part 2. And I'll just quote from the part 2 because I have an example of the bicycle brake pad. And I move it from FMEA into more of a hazard analysis or a risk management process. And the hazard is the loss of braking. And in this, we bring some of the information from the FMEA, but we have 2 additional columns. There's actually 3. One's called P1, the probability of the hazardous situation. That's the loss of braking.
Right.
And then probability P2, probability of hazardous situation leading to harm. So you might have a loss of braking. That doesn't mean you're going to have an accident.
Right.
And so you do P1 and P2, then you get the probability of occurrence of harm when you multiply them together. And so that moves from FMEA to a hazard analysis. And you can get from that, if you do it right, if you understand probabilistic risk assessment and get your probabilities correct, you'll get the probability of harm, which you don't get from an FMEA. So I just wanted to share that with listeners.
Well, it's probably why it's not in the FMEA, because that's a whole different skill set. And,
it is.
Because I'm just thinking and I've ridden a bike for years and years, a road bike, and there's plenty of hazards and plenty of circumstances and things like the rider's awareness and physical fitness and how, if it's raining, it's really hard to see, or is it clear? Or is it too sunny? Is your sunscreen dripping in your eyes? There's their emotional state, their physical fitness, their awareness, all of those things matter in avoiding accidents, independent of how good your gear is. But if the frame of my bike cracked in half and it was an immediate failure with no warning, well, there's not a whole lot I can do with that. I'm going down. There's going to be road rash.
You're going down. I know there's some type of failure modes that will bring about the bad event.
Yeah, sudden events. But that sudden event could be, I fall off the bike onto grass on the side of the road, or I fall in the middle of a busy street and get run over. That is a risk you take as a rider, and the manufacturers of bikes do a lot of work to make sure their frames are structurally sound for a long time, given the vibration and hitting potholes and rough roads and everything else. But it's quantifying that is a whole different realm than what we're doing in the FMEA. FMEA is the starting point for that further analysis, but we need to know what's the high severity, high occurrence stuff that we should go investigate more. I often look at that way, Carl, and Mike Silverman did a whole bunch of work. He tied everything to HALT, which I didn't quite agree with, but then again, he was running a lab that did HALT testing, so it was pretty natural for him to do that. But I look at FMEA as one of those tools that you do not in and of itself. It has intrinsic value of identifying things and designing them out. And that's wonderful. Yet it also creates the ability to say, we need to understand this one better, because the hazard analysis is the next step to help us refine that prevention or mitigation type things so that we really understand what we're trying to solve. But I also look at it as a stepping stone into testing. What are the things we need to be looking for? Because FMEA is not perfect. We may think there's a pad, how big of a crack in the pad is enough to cause a problem? Well, let's go do some experiments with that. And let's make sure we use cracked pads in some of the stopping force testing, and find out what do we need to know. We don't have perfect knowledge in the FMEA. So I often asterisk stuff in there going, this number is high, but we don't really know what it is. We need to go find it, find a better information, and so on and so on. I think it's a stepping stone for many activities we do.
It really is. The in some industries, like I'll just bring up the medical device industry, uses FMEA to identify situations and then brings the result where it's of high concern into the hazard analysis, so that we can be absolutely sure we understand the safety risk of something happening and what's being done to mitigate that risk. So they use both tools. Many of them use both tools, and they integrate the FMEA into they input the FMEA into the hazard analysis. Take the results of the FMEA, make it part of the hazard analysis.
I've also seen it go the other way. A lot of teams will do, because they're basically required to do a hazard analysis for their filings and FDA approval or whatever the.
Yeah, a preliminary hazard analysis can be an input to an FMEA. Absolutely correct.
Yeah, I've seen it done that way. And the ones I don't care for are the ones that just do the hazard analysis and then they wave their hands a lot and says, well, we can't put that in there because then our product won't get approved. Like,
oh gosh, that's a whole story. I know this is gonna take us a little over the normal time, Fred. But I got to throw it in here. I won't say the name of the company, but I was with a medical company years back, and there to help them with their FMEAs, and I saw the results of their FMEAs. They had no recommendations in any of their FMEAs, and I went to management, and I said, let me show you some of your FMEAs. And the recommendations column is blank. And they said, that's because we don't want to show the regulatory body that we've got problems. I said,
everything's okay.
No. You want to show them that you have problems and what you're doing to fix them. And so,
and I heard the argument too, is that, well, we don't want to tell them what we're fixing because it might change. And now they're on record looking for this. And I think it's a two-way street. Some of the regulators are like, they don't understand the development process. So it's gotten to this dynamic where, well, we don't really want to tell them what we can get away with, minimum amount. And whereas I think you and I agree is that the FMEA is a way to illustrate your organization's thinking of how you approach this thing, which is way more important than pretending you have a good product. That's the way I think of it is.
I think if I was in a regulatory body, which I haven't been, that's not been part of my career, I would want to see, here's what the product development team thinks are the concerns, and then here's what they've done to address them. And that essentially is what the FMEA is. And that it's a good representation of your thought process, like you said. So I just want to throw that in there.
Yeah, there's way too many examples of people that the regulatory organizations or the contract says thou shalt do an FMEA, and they ship the bill of material off to some other organization and they fill it out and send it back and check that box. I think some of the regulatory and contractual stuff create a dynamic that may have a good intent at some point, but they miss what you and I talk about in our book, is that you need to do FMEA when it's the right thing to do, because it'll help you in the organization create the product you're trying to do and provide information and details that you need to make good decisions. But just being mandated to do it or expected to do it often leads to a waste of time and check the box and all kinds of other things. It could be done well, and it might happen to be the right thing to do for your particular program, and it's required. And then you run into, well, we don't want to show the recommendations. We don't want to do this. We don't want to do that. It's a game playing of trying to guess the other side of the table. Well, go talk to them.
Okay, well, let's make a little side note for a podcast topic.
Oh, yeah.
Interacting with regulatory bodies in a healthy and positive way is a topic that we should talk about.
Yeah, that's going to take more than 20 minutes.
Oh. Part 1.
Part 17.
Part 1 to 10 series.
Yeah.
I mean, in all seriousness, it's really, really important because regulatory bodies can shut you down. But there's also the subject of good design practices and everything else. And I don't want to get into it, but that.
Oh, yeah, I'm biting at the bit here to get into this one.
We'll make sure that we add that to our list of topics.
There we go. Well, anyway, what were we talking about? FMEAs and
we're talking about
likelihood of severities.
The likelihood of the effect.
Yeah, likelihood of the effect that you're getting out of stuff. And so there's a couple ways to do it. Take the FMEA and use it as an input to the hazard analysis and really dive into it and get that probability of the unwanted event to occur.
Or you take a fault tree analysis and make the top event the unwanted event, and then use the fault tree to calculate the likelihood.
It's something that you have to just remember is there's always more than one way to get a bad event.
Yes. That's a law in the universe.
There is. Yeah, it definitely is. There's something about entropy for all kinds of stuff in there. But anyway, if you're listening to this and have a question or a similar question, or if we didn't quite cover this clearly enough and so on, and hopefully we did, let us know. Or if you have another question on FMEA, ask Carl, of course. Because he lives for that stuff. But any of the hosts, you can ask questions about any of us. And if we can't answer it, we know a bunch of other people that probably could give you a reasonable response or direction. And as you know, we love getting questions so that we can chat about them and learn about it and debate it in these shows. So please do send over your questions. You can head over to accendoreliability.com/go/SOR. A couple of ways to get in touch with us there. Carl and I and the other hosts of the show are available through LinkedIn and through our About pages. So there's multiple ways you can get in touch. And if you're listening to these shows on a regular basis, we do talk about questions we received on the regular is one way to phrase it. And so it's part of the show's format. So please join the discussion. I'm just thinking I'm going to go check the brake pads on my bike.
You never know.
You never know.
All right, Fred. Nice talking to you.
Yeah, thanks, Carl. Good question. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.